Sorry about that. It kicked. I accidentally closed out of the meeting after question 5. So we're going to jump back in with problem number 6. Okay. Write a polynomial function with rational coefficients in standard form whose zeros are -5, 4, and 6. Okay, first of all, reminder, look at your notes because we wrote this down a couple problems ago. What is a polynomial function in standard form? As soon as you see some terminology in a question, go to your note card and make sure you know what the question is, because a big part of all of this is what's the question. So look and make sure at your notes from before about what a polynomial function in standard form is, okay? And just like before, the easiest thing is going to get the polynomial function in. So step 1, I'm going to write the steps over here if you want to like make steps. Step 1, change zeros to factors. Step 2, write polynomial equation in factored form. Step 3, multiply factors. I'm saying these slowly because my writing is hard on the tablet. Multiply factors to get polynomial function in standard form. So I'll repeat that just to make sure you got it. Step 1, change zeros to factors. Step 2, write the polynomial equation in factored form. Step 3, multiply the factors together to get the polynomial in standard form. Okay, and I'm going to switch back to x, okay? I mean to black. So first of all, we know x equals 5. And we know to get it into factored form, we need to have a 0 over here. So we're going to subtract 5 from both sides because we need that side to be a 0. So x minus 5 is going to be one of the factors. And I know this seems obvious, but I really want you to work it out. X equals 4. Subtract 4 from both sides. X minus 4 is going to be a factor. The reason I want you to do this is they gave you the numbers easy peasy. But if these numbers were more complex, like 2/3, there would be way more involved. X equals 6. Subtract 6 from both sides. And we get x minus 6 equals 0. I just realized I did the first one wrong. That was supposed to be a -5, so we're adding 5. Okay, so now we know a polynomial function. So that's the end of step 1. So this was step 1. I'll write it over here. Step 1. And you don't have to do this. I'm just helping you to follow it. Now we're going to do step 2. We're going to write it in factored form. Okay. And again, it's just like having 3 numbers that have to get multiplied together. We multiply 2 of them together. And since they're both binomials, we're just going to do it using FOIL. I'm going to do this one shorter because it's pretty easy. So it looks like that. So we're halfway there. This one's more difficult. It's a trinomial times a binomial. I like to do those up and down. I'm going to erase all this stuff on the right. So I'll have enough room to work the multiplication because it's pretty complicated. I like to do things vertical because it's easier to line up like terms. I also like to really spread them out in case the numbers get big, so I'm not squishing things together. So if the numbers don't get big, which they don't in this one, they're going to seem really far apart, but I just don't want to take any chances. Okay, so you always want the trinomial on top. And the binomial on the bottom. Okay, so what we're going to do is we're going to pretend like the x isn't there. And we're just going to focus on the -6. And we're going to multiply the -6 by each one of these and then write it down. Okay, so -6 times -20, and you can do that on your calculator, of course, is going to be +120. And so this column here is going to be my constants column, my x column, my x squared column, and then my x cubed column. So -6 times x is -6x. Oops, I did that in the wrong spot. I guess the numbers were kind of big, so that was a positive. -6 times x squared is -6x squared. Now I'm going to repeat the process. So I finished this one. So just to kind of show that it's done, I'm kind of exit out so I know that I already took care of it. X times -20 is -20x. X times x is +x squared. And x times x cubed is, x times x squared is x cubed. So my x cubes come down. -6x squared plus x squared is going to be -5x squared. -6x plus -20x is -26x plus 120. So my final answer in standard form, and remember standard form, we talked about it earlier, you always start with your highest exponent and you go down until you end with your constant. And if you're missing one, that's okay. This one had everything, but if there hadn't been an x squared, an x term, it would have been x cubed minus 5x squared plus 120. So the final answer is x cubed minus 5x squared minus 26x plus 120. That's problem 6. Okay. Problem 7, polynomial long division. This is an easy one, and it's the kind of format that would work with synthetic division, but because it's the final, they didn't want to make it super hard. Okay. Don't forget, when you're writing your dividend, you can never skip any. So since this one is, since this is to the third power, this is to the second power, and they don't have a first power, we got to include it though. Okay, so remember, it's divide, multiply, subtract, drop. Okay, so we start with the first term and the first term. That's always the division. First term and first term. Most of you guys were really good at this. So we have 2x cubed divided by x. It's just going to be 2x squared. So after the division is when you write your answer. And notice that this is an x squared, so our answer is going to have to be above the same term. So we put a 2x squared there. Now we multiply. So we take this part of the answer and multiply it with the whole dividend. And that gives us 2x cubed plus 6x squared. Oops, I just realized I'm doing the wrong problem. I thought that looked harder. Sorry about that. I was doing problem 8 with long division. This one we didn't have to rewrite, did we? This one also would work with short division, but we didn't have to. So all the same rules that we talked about before: divide, multiply, subtract, drop. So we take the first term, divided by the first term, we get x. X times x plus 2 is x squared plus 2x. This is what gets subtracted. Notice how I put parentheses around it. Then I distribute the subtraction sign. So since these are both positive and they're being subtracted, they're both going to become negative. Now we're ready to drop our next one. Right after we subtract, we drop. 3x over x. So we take our first term and divide it by our first term. That's what's a little bit different than how you do it with regular numbers. Okay. And as soon as we do the division, that becomes part of our quotient. We take the new part of the quotient, multiply it by the divisor, and that whole thing gets subtracted. That's the answer. You could probably look at that, realize it would factor like that, and you'd be fine. So whatever long division problem you get on the final is going to be a super easy one. Okay, now we're going to do synthetic division. So just a reminder, this is one where some people forget the negatives and stuff. So for synthetic division, you just may want to do an example. That might be the easiest way to show it, is to write the example problem in whatever form that it's in. I'm not going to take time to copy it now. And then just know it only works if you have a 1 coefficient in front of the x of the divisor, which is what we've got. And we're dividing by x plus 3, so that becomes a negative. And the highest term in the dividend is x cubed. So I like to make notes to make sure I've got stuff in the right spot, and you can't skip any. So whatever exponent you start with, count down by 1 until you get to the constant. And then we're going to put the coefficients of each of those exponents from the dividend underneath. So we have a 2, a 7. There was no x term, so we're going to put 0, and the constant's negative 5. Okay, I'm going to draw a line, and I'm going to put a plus sign to remind me to do some adding. So the first one just gets dropped. I also like to put an arrow there to remind me that it gets dropped. So we have a 2. 2 times negative 3, let me put on my spotlight. 2 times negative 3 is negative 6. So we're going to add negative 6. 7 plus negative 6 is 1. 1 times negative 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is positive 9. Negative 5 plus 9 is positive 4. But we're not done yet. All this does is gives us the coefficient. You see which one they're lined up underneath? The degree is going to be 1 less than whatever they're lined up underneath. And so the answer is going to be 2x squared plus x minus 3. And then the constant, whatever is in the constant column, becomes the remainder. And then just like it was when you were a little kid, you can always write it. Instead of writing the remainder becomes the numerator, and the oops, forgot the plus sign. And the divisor becomes the denominator. And that's the answer to number 8. Okay. 9 you get to skip. We didn't do expanding binomials. And everything else is going to be from chapter 6. So we have the cube root of negative 192, a to the 7th b cubed. So a couple things. One is, now we know we've got to deal with absolute value signs. So if you don't already have this in your note card, write this down. Absolute value is needed only on even indexes and pulled out odd exponents on variables. So that's the absolute value rule, okay? So we have an odd index, so we don't have to worry about that. The other thing too, and this, we only touched on it, so you might not remember it, but negative 1 to any odd power is going to be negative 1. So as soon as you see you have an odd index and a negative underneath, you can actually rewrite the negative 1 as negative 1, and you can just match the odd index. Okay? So now, and that's going to be a negative 1. That makes the 192 positive. So we're going to factor 192. And the way I factored it was I factored it into 8 and 24. And then I factored the 8 into 2 cubed. And then I factored the 24 into 6 times 4, which just I'm sorry, 8 times 3, which just ended up being 2 cubed times 3. So my 192 looks like this. 2 cubed times 2 cubed times 3. And we know that every time I have an a cubed, I can pull it out. So just to keep it simple, because I think the whole dividing thing messed a lot of people up, a to the 7th is a cubed times a cubed, and there's one little a left over, and then the b cubed is already cubed. So it looks like that. Now let's see what pulls out. The cube root of -1 cubed is just going to be -1. So it takes care, I'm going to X these out as I do them. I'm going to switch to this. I'm going to go and make that a red too. So that one's done. The cube root of 2 cubed is 2. That one's done. The cube root of that 2 cubed is 2. That one's done. 3's to the first power, so it's going to stay underneath. It's my first one to stay underneath. The cube root of 3 cubed is going to be, the cube root of a cubed is going to be a. The cube root of that a cubed is also going to be a. And the cube root of b cubed is going to be b. So the only thing that ended up staying, oops, and then this one stayed inside. Okay, so -1 times 2 times 2 is -4. A times a is a squared. B cube root of 3a. That's how those work. Okay, now we'll do number 11. This one messed some people up on the last test. Okay, now, you may want to make some notes on what you're allowed to do and what you're not. If monomial under each radical for division, if monomial under each radical and same index can combine into a single fraction. Okay, so we keep our square root sign and we just reduce the fraction. 24 over 6 is 4. X cubed divided by x cubed. Remember, that's kind of like having 3 x's on the top, 3 x's on the bottom. They all cancel. You just get 1. Square root of 4 is 2. And that's the answer. That's number 11. Number 12. Okay, this messed some other people up on the quiz. On the test and on the quiz. Remember, when you have a time sign, as long as the indexes are matching, you can put them under a single radical sign. If it's a plus sign, you can't. Just like if we had 2x times 3y, it would be 6xy, right? If we had 2x plus 3y, you can't do anything. So just remember the rules for adding, radicals and the rules for multiplying radicals are the same as the rules for variables. I don't want to have to factor some big number, so I'm going to go ahead and factor these before I put them together. So 12 is going to be 2 squared times 3, and 15 is going to be 3 times 5. Okay, so I have the square root of 2 squared is 2, so I'm going to pull the 2 out. No 2 stay underneath. The square root of 3 squared is 3. So those are like that. The 5 stays underneath. So the answer is 6 square root of 5. And remember, that's how you handle it when you're multiplying. So if you need to write that rule down that I talked about for multiplying, when you're multiplying two monomials, you can put them under a single radical if they have matching indexes. It's actually the exact same rule as for dividing radicals. 13. 16 to the -3 halves. This one is deceptively hard. Okay, so first of all, just a reminder, this messed some folks up too. And you may want to make some notes about this. A to the negative exponent is the same as 1 over a. And if you want some examples of that, if you had a to the negative 3, that would be the same as 1 over a cubed. If you had x squared, y negative 4, z negative 2, since this one's positive, it's staying in the numerator, and all the ones that are negative are going in the denominator. So that's supposed to be a z. Okay, so that's kind of a reminder. So this is the rule, but if you need to put a couple of examples so it makes more sense to you, that's fine. So we have a negative exponent, so we're going to change it to a fraction. So then probably should have a negative over here. So the way you get rid of a negative exponent is you keep the same base, you keep the same exponent without the negative, and you put it in the denominator. Okay, now we're going to change it in order to, I don't remember what the question was for this one. In order to simplify it, we have to rationalize the denominator, which means we've got to change it to a radical. So what we're going to do is, we know that the index is going to be 5, and the exponent on the number is going to be 3. So it looks like that. Okay, now, the problem with it now is we can't have a radical sign in the denominator. So if we could get it to the 5th root of 16 to the 5th, we know it would just be 16, right? So this is where it gets a little tricky. We know we've got to have a matching index to be allowed to multiply. And we've got to think about what exponent we could put on this so that when we multiplied it by this, we would get 16x to the 5th. Because then it would, matter of fact, I'm actually just going to add this step. You don't have to if this makes sense to you, but I want to make sure I don't lose anybody. So if I want to get 16 to the 5th, if I want to get 16 to the 5th here, and I have 16 cubed here, then this power would have to be a 2. And if I'm going to keep the fraction the same, I'm going to have to multiply by 1, so that's also going to look like that. And so now we have the 5th root of 16 squared over the 5th root of 16 to the 5th. And we know that's just 16 because we did all that work to get it. And man, you'd think we'd be done. But what you're going to have to do is you square the 16. And when you square the 16, actually, we're not even going to do that. Well, yeah, we probably better. I don't know if you know how to do it without that. Let me see what it's going to be. $256. Now, got to factor it. Okay, and we know it works for 16 and 16 because we just did it. I just didn't want to confuse you guys too much. So this is going to be 2 to the 4th, and this is going to be 2 to the 4th, right? 2 times 2 times 2 times 2. So we have the 5th root of 2 to the 8th over 16, which is 5 times the 5th root of, oops, I got to keep remembering to put these 5s in here. The 5th root of 2 to the 5th times 2 cubed over 16. Oops, there's not a 5 there. That was the 5th root. I wrote it in the wrong spot. Okay. I'm really bummed that I didn't leave enough room for all this. I'm going to recopy it here. So we've got the 5th root of 2 to the 5th times 2 cubed over 16. So the 5th root of 2 to the 5th is 2. I don't know why I wrote 18 there. And the 5th root, 2 cubed, is just going to be 8 over 16. And boy, you think you'd be done, but this reduces. So the answer is the 5th root of 8 over 8. That will probably be an extra credit question on the final. That was a tough one. Okay. That was problem 13. We're going to do 14. I keep going to red and forgetting to go back to black. Okay. Okay. Over. Let me erase. Take these out because it wasn't in the original problem. So the thing you need to recognize this is if you have a square root binomial in the denominator, this is the situation where you're going to do this. Then you use the conjugate. So just make sure you know when to use conjugates. So the conjugate of square root of 3 times minus square root of 2 is the first term stays the same. Whatever sign this is becomes the opposite. So since that was negative, this is going to be positive, and the second one stays the same. When you do that, you want to slap parentheses everywhere. And we're only allowed to multiply by 1. So this, the only way this whole fraction can be 1 is if these two are an exact match. Now, the bottom one is just going to be, I ran out of room. Square root of 3 times square root of 3 is 3. A negative times a positive is negative. Square root of 2 times square root of 2 is 2. So the good news is we're going to have an easy denominator. The bad news is this one is a little bit of a mess. So multiplying by using FOIL to multiply radicals is harder than when it's just x's. So you may not want to take shortcuts when you do FOIL. You may want to go super slow and careful on these. This one's pretty simple, but a lot of them are harder than this one. So 1 times the square root of 3 is square root of 3. Outer 1 times square root of 2 is going to be square root of 2. Inner square root of 5 times square root of 3. Since the part that's under the square root stays together, that's going to be the square root of 15. And then the square root of 5 times the square root of 2 is the square root of 10. And let's see if any of these simplify. This is, let me get a spotlight. Square root of 3, of course, doesn't simplify. Neither is that. That's 3 times 5. That's not going to simplify. That's 2 times 5. That's not going to simplify. So we end up with square root of 3 plus square root of 2 plus square root of 15 plus square root of 10. 3 minus 2 is just 1. So this ends up going away, and this ends up being your final answer. So that was 14. 15. Okay, so this is called solving if you have to solve a radical equation. The reason it's equation, there's no f of x's, there's no y's, there's just x's. You know it's an equation because there's an equal sign, and you know it's a radical because there's a square root sign. So the rules for solving a radical equation, step 1, isolate the radical. Step 2, raise to a power to get rid of the radical. Since it's a square root, we're going to raise to the second power. If it had been a cube root, we'd have raised to the cubic power. So we're going to raise it. This one was already isolated. Okay. The square root of anything squared is itself. A lot of people mess this up. I'm going to put something here. I'm going to do it in red because this is not true. X plus 5 squared, you can't distribute it because of the plus sign. It is not x squared plus 25. Big ol' X. So let me get rid of some of that because that's what it's not. We'll go back to black because this is what it really is. X plus 5 squared is really x plus 5 times x plus 5, and we'll FOIL it. X squared plus 10x plus 25. So I'm going to copy it here. I'm going to erase all this mess. Now, I've said this before earlier, and this is still messing a lot of people up. At the point when you don't have any radical signs, you need to study what you have and think about it. You got to think about what kind of an equation is this. I'm going to let you think about that for a minute and answer it. You look at the highest power. The highest power on x, the highest exponent is a 2. So it's a quadratic. So you've got to jump back to your infinite knowledge of chapter 3, actually chapter 4, and solve a quadratic. So the way you solve a quadratic is you get 0 on one side and everything else on the other. So I'm going to subtract 1 and add x. I'm going to do it all in one step just because this is getting to be a long video. And so the x squared doesn't change. We added an x, so we have 11x. And we subtracted a 1, so we have 24. Now we're going to use all the rules we've talked about a lot. Now you've got to solve a quadratic equation. And I'm not going to write down these rules again. I want you to look back on your note card that hopefully you added a few minutes ago. But I am going to erase, isolate the radical, raise to a power to get rid of the radical, and then solve. Okay, so for this one, I'm going to do the diamond method. B is 11, AC is 24. They're both positive. So I'm going to think of two positive numbers that add to make 11, multiply to make 24. It's about as good as it gets. So we know it's going to be x plus 3 and x plus 8. So now we factored our quadratic. We set it, and it's equal to 0. We set each factor equal to 0. Now, if this had only been a quadratic and we had started at this point, we'd be done. But since we started with the square root sign, there's a possibility that one or more of these are going to be extraneous, and we have to check them. So I'm going to erase this stuff over here. Okay. And I'm just going to do this really quick. So we have 1 minus negative 3 equal x plus 5. Square root of 4 oops, not x, negative 3. So because we had to replace the x's on both, negative 3 plus 5 is 2, square root of 4 is 2, so that checks. So x equal negative 3 is a solution. Now we've got to check x equal negative 8. So we have the square root of 1 minus negative 8 equal negative 8 plus 5. 1 minus negative 8 is 9. Square root of 9 is 3. Negative 8 plus 5 is negative 3. That's not true, so x equal negative 8 is extraneous. So we have x equal negative 3 is a solution, and x equal negative 8 is extraneous. Almost done. 17. F minus g of x. These were in, I think it was section 6.7, and a lot of people missed these on the test, so you may want to go back to the review section for this and do a couple of the extras. You'll be responsible for the adding, subtracting, multiplying, and dividing, but not composites, okay? So we know that f minus g of x is f of x minus g of x. So I'm just going to replace. So they told us f of x was x minus 2. We have a minus, and they told us g of x was 4 minus 3x squared. Okay, so it's really a 1 there, so we can drop these parentheses. So we have x plus negative 2 minus 4 plus 3x squared. So I distributed that negative. Negative times a negative and a positive is a negative and a negative is a positive. I'm sorry, negative and a positive is a negative, negative and negative is positive. So now I've got to write it in descending order. So I have 3x squared plus x minus 6. And that's what f minus g of x is. Okay, that was 17. Last one. Almost everyone got this one right on the test. We had to graph the equation y equal the square root of x plus 3 minus 1. Okay, so basically, and you had to find the domain and range. So domain and range. Okay, so first of all, we know we can't take this. When you graph it and you look at it, you always want to go to table and find some points. So if you go to table and find some points, first of all, notice where the error message is. You had an error at x equal -4, and it started working at x equal 3, and when x equaled 3, y equal -1, and that appeared to be the starting point. Here's why that works, because when x, I'm sorry, -3, x was -3, y was +1. I'm sorry, y was -1. I was reading my, can't read my own handwriting, okay? So that was the first point that you were able to see. And that makes sense because you can't take the square root of a negative number. So if x was less than -3, then a -4 plus a 3 would have been a -1, and it wouldn't have been real, and that's what kicked it out. So we know that our graph is going to start here. That means as long as x is bigger than -3, this whole thing is going to be positive, and it'll be a part of the domain. So we know our x is such that x is greater than or equal to -3. Okay? And when we graphed it, we noticed that y was going up. And so the smallest y ever was is when x was -3. So our range is going to be y such that y is greater than or equal to -1. And then when you graphed it and you go to table, we're going to look at some more points. So the first point obviously was our starting point of our graph. And if you look at the other integer points, they're going to be 1, 1, and 6, 2. So you can definitely plot those, but we need some more to make sure we draw a smooth curve. So we'll definitely plot those 3. And we know it's going to, since x is greater than or equal to -3, we know after we draw a curve, we're going to have an arrow on the right side going out. And so our points were -3, -1, and then we had 1, 1, and 6, 2. So something like that. And then you want to slap in some other points. So I just chose, because we need a better curve, so I chose x equal -1, and I got like a positive 0.4. So I put it as close as I could. And then I chose x equal 3, and I got a 1.5. And then I chose 7 and 2.16, like as it was jumping off the graph. And mine's going to be really bad because it's a tablet. I'm going to do it in red so that you can see it. I'm going to try and pass through these points as best I can. I'm going to put an arrow on it. So it starts here. There's no arrow on this side because I can't go lower than that. This is my bottoming out of my domain and my range. Okay? And I put a smooth curve on there. Okay? That's the last one. I know that was kind of long. And like I said, if you're watching this one and you're wondering where 1 through 5 was, I accidentally shut off the recording and I didn't want to retape them. So you can go back and watch. There's 3 YouTube videos. The first one is the quarter 1 test. The second one was problems 1 through 5. And then this was the end. I hope everyone's having a great Thanksgiving, and I will see everybody on either Monday or Wednesday. Bye.